Well, I'm back with an update on the Orion R545A, and I managed to stabilize this coil assembly. Well, the glue isn't quite dry yet, but I used a kind of super glue gel, and unfortunately being super glue gel, it takes a little while for it to harden, to stiffen up. So what am I going to do? Well, as soon as the super glue has set and is completely hard again, then I'm going to start cleaning the chassis, because I could start work on it immediately without cleaning the chassis, but that would be rather foolish, I think, because if I left it dirty as it is, then I might miss obvious problems within the chassis. Okay, so I did manage to clean up the chassis from most of the dirt and dust which was caked on it. Now, it might not seem a lot cleaner than a few minutes ago, but trust me, I'm looking straight at it and it is a lot cleaner. At least now I can read all the values and I can see with what kind of parts I'm dealing here. Now, this chassis is obviously full of what some of you call dog bone resistors, and since this chassis looks pretty original to me, I mean all the parts at least look original to me, I'm going to make a conscious effort to leave all the original parts that I can leave in this chassis, and if I'm going to replace something, well, in first instance I'm going to replace probably most of the capacitors, while I'm going to do my best to reuse the old capacitors, like these black ones here, this one or that one down here, yeah, this one and this one here, or these cardboard ones like this large one along the speaker, or this one close to the AC cord. Well, I'm going to try to reuse those capacitors. Now, I'm going to use a trick which most of you know, which is that I'm going to solder out or solder loose these old capacitors and then apply some heat on them and extract their innards that way. Or if that is not possible, then I'll try to make a nice clean cut along the capacitor lengthwise, and I'm going to eviscerate it that way. Now, like I said, the method I'll use to recycle, as it were, those capacitors will largely depend on what type of capacitor they are and how they are constructed. But we'll see. Now, obviously, those dog bone resistors, and if there are capacitors inside of here which are also dog bone style, well, those will pose a bigger problem. It's quite difficult to reuse those to camouflage new parts. Well, in instance, you know, I use metal film resistors most of the time, and although those resistors are quite small, I don't see how I could reuse an old dog bone resistor like this one here, for example, and reuse it to hide a new style resistor. I mean, these dog bone resistors, some of them are hollow, like this one, but the space inside of them is really very, very small. Yeah, and I doubt I could get a resistor inside of them. I could try, but, well, seeing their size, very unlikely. Now, after I cleaned the inside of the chassis, by the way, I used a simple brush and a vacuum cleaner on those parts which are safe to vacuum. Obviously, I tried to avoid this area where all the RF coils are located. Now, so in other words, after I finished cleaning, I did notice one coil had a loose connection, which is this one. I don't know if you can see it because the wire is extremely thin, but this wire let loose somewhere down inside the chassis, and I'll have to look where it might have been connected. I don't know yet, but I'll look on the schematic, and I think most of you, and I certainly hope all of you, will, if they are confronted with a problem like I am, check on their schematic first. Now, like I said, there is at least one coil with a loose connection. So that coil, and in this instance connected to the first knob, this knob here, which I think is band 1 on the radio, well, that coil is disconnected, so I'll have to check that. Now, as I went deeper inside the chassis, for example there, I found a part where the wires are simply twisted together. Now, although the part looks original enough to me, I am wondering whether this was done in the factory or not. I certainly hope not, because it doesn't really look very trustworthy. Also, it is connected to a tiny wire leading to this high frequency coil. So I'm not too happy about this arrangement here. I might have to check that too. Also, I'm sure you all noticed that there are quite a few capacitors buried deep down inside the chassis. Now, like this one here. Now that is really a pain. I mean, you can see this one, for example. This one here is buried deep inside the chassis too. If you see how small this chassis is, I mean, compared to my hand, you can tell this chassis is not much wider than a hand. And you see how many parts are crammed inside this tiny space, which is about as wide as a palm of a hand. Well, now you can imagine replacing those capacitors will be a pain to do. And well, truth be told, I'm not looking forward to doing that, because well, that is really messy and difficult to do. But okay, that's what it takes, so I'll do it, of course. But like I said, it's really not with a lot of pleasure. Okay, so while I was cleaning the lower part, okay, hang on. Hang on. Okay, we're almost there. Right. Okay, so while I was cleaning the top side of the radio, I noticed this little gizmo here. Now you can see this flywheel here, and if you look carefully at this wheel over there, while I move this flywheel, you see that the wheel over there is turning, but only very, very, very slightly so. Now, I was wondering at first what the heck that could be. Now take a look inside there. So, in there, you see this tube over there. Yeah, you see this tube here, where I'm pointing at. Now, this tube is a coil assembly, and this wire, which is looped around this little wheel here, this wire moves a kernel back and forth inside that coil tube. So inside of there, a kernel is moved back and forth by actioning this wheel. This wheel, by the way, this flywheel here, is connected to the dial mechanism here. So if I turn this, the flywheel, as you can see, moves along. Yeah, and it actions a shaft which you see over there. So, and that shaft pulls along the kernel inside the tube down there, as you can see. Yeah. So now I haven't seen this type of how should I say, of tuning mechanism before. It's rather bizarre. I really don't know why they did it that way, except perhaps to save perhaps some money, because I guess mounting another variable capacitor up here would have cost more than the little mechanism they built for tuning this radio. Although it seems really overcomplicated to me. But, well, obviously if I would have designed something, a tuning mechanism, I would have avoided at all costs having to manufacture an assembly with a coil, because coils are notoriously difficult to align correctly inside any radio frequency equipment. So yeah, it's a kind of peculiar arrangement, but I suppose it must have worked. So I guess I'll have to make do with what it is and try to make it work again. Now, so that will prove interesting too. Okay, so now something else. You'll notice that I took away the paper screen that was between those two pins, those two axes. And I finally realized how it works and why they used a paper screen. So the paper screen, inside, or rather between the two sides of the paper screen, because it was a continuous loop of paper, so inside that paper loop moved this pointer. So this pointer here. Now, at first I thought the pointer was broken. So you see the little red tip here. So I thought the pin had broken off. But actually it isn't. What it is quite simple. The folded paper, or the continuous loop of paper, had this pointer here inside of it. So this moved in between, effectively, two sheets of paper. And it moved back and forth between those sheets of paper. And behind the sheet of paper, there is a little dial light, which you see down there. So what this is actually, or what this actually is a kind of shadow meter, actually. So this pin here, this dial pin, which moves back and forth, would cast a shadow on the inside of the paper. And the paper being illuminated from the back, from here, would cast a shadow to the front layer of paper. And therefore, you'd be able to follow where the needle pointer is. And that way you could read out the frequency you were tuning to. Now, I can't imagine this being a very accurate mechanism to dial any frequency. And, well, you know, also paper turns yellow over the years, and it crinkles and it gets dirty. And also paper is flammable, and to put paper close to an incandescent light bulb, even if it doesn't burn too brightly, well, in my opinion, is not a very clever move. So whomever designed that, well, was not too clever in my opinion. But okay, that's how they designed it. So I guess I'll have to find a substitution material for the paper band which was here, because obviously, well, I'm really too scared of putting paper close to a heat source. I'm too scared of fire, so I'm certainly not going to leave the dial backlight as it was. So there we are. I'm ready to disassemble the ferrite antenna from the capacitor. The reason why I intend to do that is because if I want to get inside the electrolytic, then obviously this construction with the ferrite rod is going to hamper me. Now notice that the rod is kept in place on two metal forks. You see here, one here, one here. Now let me give you more light. So there's a fork here and one here, yeah, and the ferrite rod rests on both forks and is kept in place by a rubber band on both ends. Now that doesn't look very solid to me, so I'll have to replace that mechanism too. or at least improve a little bit, because it's certainly not too good. Okay, so the ferrite rod is attached to the electrolytic can here, but notice too that between the foot of the ferrite rod assembly and the capacitor there is a kind of a, well, I would say oiled paper. I guess to insulate the ferrite rod from the capacitor can, because I suspect the capacitor can is the ground. So hang on, I'm trying to slip it off carefully. Yep, there we go. Okay, now okay, so I'm going to lay the coil here out of the way safely. So the electrolytic can is mounted to the chassis with a clamp. You see here the clamp. So to release it from the chassis I need to undo the clamp. So let's see if I can do it with one hand. Not really. Okay, hang on. Oh no, I need both my hands for that, because there is a bolt. Okay, hang on. That is exactly what I'm going to do. I'm going to clamp the bolt with one hand while I loosen the screw here. Okay, there you go. Okay, no need to undo the screw completely, just as long as the capacitor is loose enough so that I can unmount it, that's plenty. Okay, now let's see if we can turn the whole thing a little bit more so that I have a better view on it. Okay, and that's pretty solidly wedged. Okay, so hang on. Okay, well, I'm going to release the oiled paper they stuck on it to protect. Yeah, there you go. So what does it say? Oh, okay. It's a Tesla. It's a Tesla capacitor can, electrolytic capacitor can, and inside it has two 50 microfarad capacitors rated at 350 to 385 volts. And as you can see, it was made in Czechoslovakia. So you'll remember that I wasn't sure whether this radio was of a Hungarian brand. You know, I don't know if Orion is Czechoslovakian or Hungarian, but at least Tesla, as you can see, seems to be made in Czechoslovakia. That's a nice little touch. So I'll try to save this electrolytic can, and by saving I mean I won't be cutting it, but I will be gutting it. So I will have to gut it to take out the two 50 microfarad capacitors in here. Now I don't have 50 microfarad capacitors on hand, but what I do have is 47 microfarad. So I think those will do nicely, provided I can fit two of them inside this can. And that I'm not entirely sure. I think it will be possible, but I'm not quite sure about of it. But we'll see about that. So there you are. I released the assembly, the ferrite rod assembly. So as you can see, it's a kind of a clamp with two phenolic plastic forks held in place and rubber bands hooked over the phenolic plastic forks and holding the ferrite rod clamped to this metal band. But I really have to be careful because I can't, well, I suppose I could release the ferrite rod from the two connections you see here. So the ferrite rod is connected here to these two contacts. So I could try to unsolder the ferrite rod so that I can set it aside and not ruin it, because well, that would be kind of a problem if I ruined it. So yeah, what am I going to do? I'm going to try to disconnect the ferrite antenna, and then my very first job will be to gut this electrolytic can and replace its contents with two modern electrolytic capacitors. Once that is done and out of the way, then I can continue with all the smaller capacitors on the chassis. Well, and here is the unmounted electrolytic capacitor from the Orion 545A. And well, like I said before, as you can see for yourself, it's a double 50 microfarad electrolytic capacitor rated for 350 to 385 volts of the brand Tesla. And if you take a good look at the bottom, well, I think you can see for yourselves the bottom of the capacitor has bulged quite a bit. So I think this capacitor is end of life. It feels quite heavy, I have to say, but seeing how its bottom plate is bulging, I don't think it could have lasted another moment of use. In fact, I'm pretty certain it would not have lasted another use. Okay, so this can is really cool. Yeah, it's one aluminum can with no indentations, no nothing. It's just a rounded can. So I don't think, well, in fact, I'm quite certain I won't make a cut into this can. What I'm going to try is to pry open its edge gently and then see if I can take out its innards through its top. Covering the bottom of the electrolytic was this cardboard, this little piece of cardboard, but it was on top of the capacitor, not inside of it. Okay, so I worked up carefully the crimped edge, and I used a needle nose plier with a curved nose and no serrations inside to keep damage to the edge to a minimum. And then I made a fine cut to this rubber seal, you know, all along the edge of it. I cut a thin strip with my trusted surgical knife, and it let go, as you can see. And below, I don't know what it is, but it looks like a piece of phenolic plastic, and underneath is the capacitor. So what I'm going to do now is see whether I can pull it out with some pliers by tugging at these contacts here. And if that doesn't work, then I'm going to apply a little bit of heat to the can and then see whether I can release the capacitors inside. So here we go. Okay, I'm ready to gut the capacitor, and I'm using this tool. You know, it's a screwdriver handle with interchangeable tips, and I have this drill tip attached to it. So as you can see, I tried to pull loose the cap from the electrolytic, but that didn't work out too well. So what I'm going to do is to drill inside or into this electrolytic capacitor roll and then pull it out. Well, at least I hope I can pull it out, so here we go. It takes quite a bit of force, you know. Okay, here we go. We're inside. We're inside of the electrolytic. Okay, so now, okay, I think it will come out. So here we go. Okay. Here we go, here we go. Yep. Yep. There we are. Voila. And this is the inside of that electrolytic capacitor. Well, by now I think you all know what it is. It's just a roll of paper and aluminum foil rolled together and soaked in some sort of electrolytic solution. So it's a mighty heavy roll too, I can tell you. It's for its size, it's pretty hefty. Anyway, I'm not going to keep this. This goes straight into the garbage can. It's way too unhealthy to keep this because, well, you never know what kind of chemicals are inside of it. Anyway, to keep the roll in its place inside the tube, they used a piece of cardboard material like this. Well, at least I think it's cardboard, but they wedged this alongside the capacitor roll, and that way wedged it inside the can. The can is surprisingly clean inside, so that's great. That's a little bit less work. And then on top of the roll, this was mounted. Well, okay, I think the mass contact of the capacitor was squeezed in between this plate and the top part of the capacitor cylinder. Okay, so that's it for now. Now I'm going to replace the old electrolytic roll with new capacitors, and then I'm going to seal it up again. Okay, I'm going to replace the very first capacitor that was placed on this chassis, and in fact it's the capacitor that connects the chassis up to the antenna input. Now, as you can see, it's a 220 picofarad, 1 kilovolt rated capacitor, and it's a black tube. I think it's painted cardboard, and with a capacitor mounted inside, and the ends feel pliable, like it would be wax or something like that. So since the chassis is in reasonably good state, reasonably good state, and it was constructed of all its original parts, at least as far as I can make out, I decided that I would try to keep as much as possible its original looks. So I'm going to replace the capacitor you see here with one of these. And one of these tiny blue capacitors you see here, or 220 picofarad like this one is, but well, and they are also rated for 1 kilovolt. Now imagine that such a tiny capacitor as this does the same thing as this large tube. Isn't that astonishing? Well, anyway, I think with a little bit of pushing and shoving, I think I can manage to put this little capacitor inside of this tube. By the way, the capacitor, as most of the capacitors on this chassis, are of the brand Remix, or Remix, I think they would pronounce it. And it's interesting. It looks like cardboard, plastified cardboard. Well, let's try. And there you go. I emptied the capacitor. Let me give you a little bit more light. So this was inside of the tube. Yeah, it looks like a small roll of paper, but well, it's hard to tell because it's coated with a layer of blackish stuff. Maybe it is tar. Anyway, I heated up this little roll with a heat gun, not too long actually, and then I simply pulled on one end and it just slid out very easily. Now, to place the little capacitor inside, well, probably I will manage with a little bit of pushing and shoving. I think I can get this little capacitor inside of this tube, and I'll reuse some of the tar which is still on top of the wire here. Yeah, so I'm going to try to reuse this. Interestingly enough, the tar on the other end is still there. So with a bit of luck, I might just have to restore this end. Also, I think I'm going to use the original wires that were attached to this capacitor. In any case, the wires were a little bit too long, so they were over-dimensioned. So if I snip off just a little bit, they will still be fine for use. So here we go. It turned out to be rather easy to stuff the capacitor inside, the new capacitor inside of the casing of the old capacitor. And as you can see, I reused the wires too, the leads of the old capacitor, and by using the tar that was on top of the capacitors, I managed to seal it off again. Actually, the sealing off was quite simple. I just put the wires through the remains of the tar at both ends, and then I lightly melted it with my solder iron, and by lightly melting it I managed to form it into a kind of a cone, you know, on both sides, by the way, and thus I managed to seal off the whole capacitor, as you can see, and it looks quite original too. So this one is ready to mount, and I'll be moving on. And there you are, 3 capacitors replaced. You might say, well, what's the big deal? It's only 3 capacitors. But changing or replacing those 3 capacitors took me nearly 2 hours. Yeah, because I gutted this electrolytic and placed a 400 volts 22 microfarad inside of it. According to the schematic, it should be a 25 microfarad, but that's a very uncommon value, and I had 22 microfarads on hand, so I went ahead and replaced the capacitor inside, and here it is, the old one. You know, just a classical paper and aluminum foil roll steeped in some kind of electrolytic fluid. Yeah. So this capacitor measured only about 5 microfarads, so it's pretty much dried out, so it wouldn't have functioned much longer, I think. So there you go. I used the old capacitor housings to fill them up with a new capacitor inside, which is great. So the next step is to replace those capacitors around the speaker over there, these 2, and then when that is done, I'll move to the underside of the chassis and start replacing the capacitors there. The reason why I haven't replaced the electrolytic can yet is because I need 2 47 microfarad 450 volt or 400 volt capacitors, and the only ones I have on hand are 250 volts, so too low. So I guess you'll have to wait a little bit longer to see that one finished. That's it for now.